are three consecutive terms of an exponential sequence, GP. If the first term of the linear sequence is 7, find its common difference. So now, the general formula for finding the nth term, un, of a linear sequence is equal to the first term, a, plus, into brackets, n minus 1 times the common difference, d. So for the first term, it's equal to 1. So that will be a plus, into brackets, 1 minus 1 times d. And this is equal to a. Then for the second term, it's equal to a plus, into brackets. So second term, that's 2. So 2 minus 1 times d. 2 minus 1 is 1. So this becomes a plus d. Then the fifth term, so that is equal to a plus, into brackets, n is 5. So 5 minus 1 times d. And that's equal to a plus 4d. A, and then a plus d, which is the second term, and then the fifth term, a plus 4d, are consecutive terms of a geometric sequence. So since this is a geometric sequence, what we can find is the common ratio. Now the common ratio is the second term divided by the first term. So that is a plus d divided by a. Now we can also find the common ratio between these two terms. So another expression for the common ratio is a plus 4d divided by a plus d. So this means that this is a common ratio, this is a common ratio. So we can equate these two equations. So a plus d divided by a is equal to a plus 4d divided by a plus d. So we need to cross multiply. So if we cross multiply, it will become a plus a times a plus 4d equals, now here's a plus d, here's a plus d. So that is a plus d times a plus d, which is a plus d squared. Now we can use binomial expansion here. If we have a plus b all squared, it's equal to a squared plus 2 times a times b, which is 2ab, then plus b squared. So now a times a is a squared, then a times 4d is plus 4ad equals, now let's apply the binomial expansion here. So that's a squared, then plus 2 times a times d is 2ad, then plus d squared. So you can see that a squared and a squared will cancel. So bringing everything to the right hand side, we have d squared, then plus 2ad minus 4ad equals 0. So we are left with d squared, then minus 2ad equals 0. So we can factorize d out. We are left with d minus 2a equals 0. So there are two values for d. It's either d is equal to 0 or d is equal to 2a. However, d cannot be equal to 0. The reason is because the question says that these consecutive terms are also terms of a linear sequence. So for a linear sequence, to move to the next term, d must definitely not be 0, else 0 is the identity for addition, and therefore d cannot be 0. So d is equal to 2a. But from the question, it says that the first term is 7, and then the first term is a. So d is equal to 2 times 7, which is equal to 14. So